Alright, so kicking off with overview of what I changed since the last video. So the major changes have been turning the system from a single knowledge base system to a multi-knowledge base system. What that means is that instead of creating a single database and then asking questions based on that knowledge base, now I can create multiple ones and then direct the questions to specific knowledge bases for specific research domains. Uh, and the way this is all orchestrated is through the ETL GUI. You can either create a new knowledge base or you can update an existing one. Um, this included the addition of an additional stage to the ETL pipeline, which is basically just upserting the data to the vector database right after the upserting to the knowledge graph database. Uh, the other addition is filtering. The kind of filters included now are year ranges, number of citations, retraction status, keyword filtering, publication status, and item type. Publication status, I usually keep that one off because for some reason the metadata associated with articles within Crossref or OpenAlex, it'll say an article is not published when in fact it is published and peer reviewed and hosted on the publisher's website for their respective journal. And as far as the metadata that we collect during this pipeline, we have I think over 15 pieces of metadata here. The DOI, abstract, authors, date, journal, publisher, and primary topic, which is a dictionary, which includes the primary topic name, the topic score, subfield, field, domain, uh, and if it has a PDF link, we also store that as metadata. Uh, so jumping into current limitations with the PDF retrieval. So currently, after where is it stage after stage two, I only run up until stage two because most of the major publishers, MDPI and Elsevier, they block access from the links in paywall. So for those, I needed to develop some workarounds. So the workarounds I developed, now we can collect the missing articles from NDPI and other journals like Frontiers and Oxford using the method I developed. But that same method doesn't work for the biggest publisher for most research, that being Elsevier, which controls thousands of different journals, publications. This is a major limitation because I can't use the additional automated extraction I developed for MDPI, Oxford, and Frontiers because they block basically any attempt for automated extraction. So for this, I developed a semi-automated extraction where we can still collect all those articles, but it just takes time, and depending on how fast you're extracting those articles, you will get your IP banned by Elsevier, and then you have to either restart your router to get a new IP or just go somewhere with different Wi-Fi or university library or using university Wi-Fi to get those missing articles. The reason why they do this is because they want you to use uh, their own API to get these articles, uh, which you can access through their developer portal. But the API they provide people, it doesn't include full text, so you don't get the full text article. They do this because even though they say it's all open access, it should be free. Uh, this API is geared towards institutions, which they require institutions to subscribe as an additional service to whatever services they provide institutions. Uh, I don't know how much institutions pay publishers like Elsevier, but I'm sure that the reason why they do this is because they want to extract more money from the institution. So uh, right now we have the workarounds to get these articles, but it adds time and complexity to the process, um, and it makes it less seamless. To make it more seamless, you have to get access to that API, which will require collaboration either through institutional library um, or contacting Elsevier and then buying that license. But for a person like me, that's not really uh, not really an option because I don't have millions of dollars to spend. Uh, so some institutions might already have this API access. So if we're working with an institution that has it, then good. We can just use our API key here, and then the process will continue as it should. Um, but without it, we're stuck with stopping at stage two and getting those missing articles, and then continuing from there. That's one of the major limitations we have right now. And here we have information about the API access uh, and the developer portal. But yeah, it's the university I'm at currently doesn't have access to this API. Other institutions might, so a collaboration with those institutions might prove fruitful, but that would also require for the infrastructure to be hosted on that institution's network, because if the API is not being accessed through that institution's network, they'll block the API. Uh, so, doing a brief recap of the infrastructure, what we had before the pipeline was geared towards a single use, so the only person that was benefiting from this was myself. You go through the traditional stages, all 7 stages or 8 now, and then you get the final two databases, and you can start asking the questions that way. Um, Now it's been reconfigured into a multi-tenant design where we can host multiple knowledge bases for multiple users, multiple teams, uh, with the addition of the of knowledge graph visualizations, which makes us truly into an integrated research platform. Um, but to create the knowledge bases, we still go through the previous steps. It's just that now, once the knowledge base is created, it'll be ready for use through the user interface, which is also hosted on my machine. So you do go through Nginx and Cloudflare to access it. That's for security, but the main thing of this is that everything is hosted on my machine. So right now, the only associated costs are paying for the Cloudflare monthly protection and the open router calls for the actual RAG part. So the existing infrastructure, what I have right now, is a workstation with 4 GPUs, uh, tons of RAM. But even with this infrastructure right now, I can't fully utilize it because to be able to use all 4 GPUs, I need to pull around 2200 watts of power. Um, Although I have access to a power supply unit that can supply that, I can't use it because I don't have access to the appropriate power outlet, which requires 220 to 240 volts AC. Those outlets are usually for your stove or your dryer, um, but I can't. It wouldn't be reasonable for me to replace my stove with my workstation, although it'll still generate the same kind of heat. You can't. It wouldn't be reasonable to do that. So here, a logical next step is to basically move the workstation to somewhere where I can actually run it and make full use of the existing infrastructure. Uh, but say an institution is interested, or a research team is interested in using this kind of workflow for their research. If you develop your own workstation to do this, it will cost around 17 to $20,000, but that's uh, through a gray market approach, and by gray market I mean sourcing components from eBay, Amazon, or vendors in Asian countries. Uh, Institutional customers are usually limited to whatever they have contracted as vendors. So for a comparable system, they'd probably pay like $50,000 to $60,000, even though they could end up getting something that either performs at a slower throughput or what have you. But you know, 17 to $20,000, that sounds a lot, but comparing it to cloud services, when I was doing this before I built my infrastructure, it would cost around $450 to create a single knowledge base. But if you wanted to scale this to an entire academic department or a research team where you might have like 20 different knowledge bases for diverse teams, you could end up paying more in cloud costs than you would for the initial infrastructure. Um, so right now, the cost, if I were to compare it to what I was paying before it was $450 for creating a knowledge base with 400, 600 articles. Right now, it's like $3 because the only real cost is electricity plus the initial investment. But eventually that pays off. So the next steps for the ETL pipeline includes moving the workstation to somewhere that supports the uh, power draw for the system, and also working with institutions that have access to the correct Elsevier Science Direct API. So the user interface right now I'm working with Streamlit, but I'm planning on migrating from Streamlit to a more to a better front end, either developing my own using JavaScript and CSS or HTML, which will probably take months, or something like Plotly Dash's framework. Uh, but the user interface right now, you have the retrieval augmented generation Q&A interface, you have the post-RAG review interface, and the Knowledge Graph Explorer. Limitations with the existing front end is that it's buggy due to the Streamlit framework, where each interaction basically reruns the entire page. Uh, Most of the knowledge graph functionality is hard coded to specific values, so if you want to see more than, like, say for authors, if you want to see more than 20 authors, you can't really do that right now until we migrate to a different front end framework. And any further changes at this point will be dependent on user feedback. Uh, and development is currently stalled pending the replacement of Streamlit. So the RAG Q&A interface, that's basically where you ask your research questions. It's split into three main components: Section A, your observations; Section B, the alignment explanation, which explains why given observations were made, or why a provisional answer was generated. And then you have the what I call the agentic reasoning, which is basically the LLM's reasoning as to why it either allowed a provisional answer to be displayed or why it rejected it. And then the QA report, which is the final summary. Working context: this you have the option to either sharing your keeping your Q&A thing limited to only yourself, or if you're working with a team, you can display uh, the responses with your team. Post-RAG interface here, after you ask a question in the Q&A interface, those responses are sent over to the post-RAG interface, where here you review the LLM's outputs for their observations against the source material being the full text article. And here you have the option of either reading the markdown formatted full text, or you can view the PDF in the PDF viewer, or download the PDF and read it that way. Uh, and then once you're done reviewing the article, you can write your notes in the notes section. Good or bad refers to whether the observation made by the LLM matches what's in the article, uh, and then of course whatever notes you're taking based on the article. Uh, Additionally, you have the Knowledge Graph Explorer now. Here you have, I think, several different analysis options to explore your research domain or knowledge base, which allows you to visualize and interact with your research topic in a way that is deeper than comparable systems like Elicit or Research Rabbit, where their visualizations are based on citations and who references who. Here we do it based on the content and context of the actual articles and the themes within those articles. Uh, so the roadmap here, of course, as previously mentioned, is to migrate off of Streamlit into a more developer-friendly front-end framework. So how are you supposed to use this? So the way you're supposed to use it is you start at the knowledge graph interface first. to get a visual understanding of your research domain based on the topics that you have available there. This will allow you to develop your research questions. Once you have your research question, you move on to the RAG Research Assistant, ask your questions there. Then you review the outputs in the post-RAG review. You read the responses, make your notes, uh, and then if any article is of interest to you, you have the DOI or the research or the article title. So then you go back into the knowledge graph interface, and you can do an article deep dive, and then see connected articles or explore the themes of that article that you're doing a deep dive on. Um, then rinse and repeat. So comparable systems. Right now, the ones I've been able to identify are Paper QA2, Elicit, Consensus, Site AI, Iris AI RSpace, Research Rabbit, Connected Papers, Lightmaps, Insightful. Uh, Research Rabbit, Connected Papers, Lightmaps, Insightful, those are knowledge graph visualization tools which work off of citations or who references who. Uh, Major difference is that instead of using references or citations here in our system, we're using the actual themes and content from the articles to map articles that way. It also does references and citations, but that's really, I don't think that's a good way of exploring articles, uh, at least in the way where you can actually find gaps and develop research topics. Paper QA, that does what the RAG interface does, where you can do Q&A, but that's for individual articles. Elicit, similar to Paper QA, but that extracts data points from the article, so that kind of mirrors what we do with the field extraction. Consensus, that helps you find related articles to your topic. Same with Site AI. Iris AI RSpace, that's the most similar one to my framework. Uh, does most of what I uh, what I do with the ETL pipeline and then the user interface, but it's geared more towards enterprise customers. Uh, Moving on from there, well, that's it. We have for the presentation. Within this PowerPoint, I also add a link to the actual demonstration of the user interface. Thank you for watching. Have a good day.